have problems, call corporate Panera. So I did. I called them and I left the angriest voicemail. I'm like, I am sitting in your Panera in St. Joseph, Michigan, and I have just been served a dinner roll instead of my usual baguette. I am livid. This is unacceptable. I expected a baguette made from Panera, and I received a dinner roll that could have been out of a frozen package. I am livid. This is unacceptable. This needs to be fixed. And it was a voicemail. There wasn't anybody else on the line. I just left a voicemail.
You should have left like their address, maybe like send you coupons or something.
No,
Guys, I recorded all of that and I'm posting it on TeacherTube. Second of all,
You should. There needs to be some kind of awareness.
some kind of awareness. All right, so shh.
That would be a lot.
Shh. Let's do problem number 18, okay?
Yeah.
There should be some sort of awareness. That is hilarious. All right, so now for problem number 18, what we want to do is we want to find the inverse of this. So the first step in finding an inverse, I guess what we should do first, it helps us to determine if it's a one-to-one function. So what I could do is I could just come in here and plug the function into my calculator and then do the horizontal line test. And let's do that. So it's x raised to the 2/3. All right, and then I'm going to hit enter and we'll graph it. Yeah. Oh wait.
So no?
No.
You just can't do it.
No. Oh, but look what it says. They gave us a parameter on the diameter, so we're really only looking at from here to here.
Yeah.
So and because of the way they define it technically, that is one-to-one, right? So if we totally ignore the left half of this graph, right? Does that make sense? If we totally ignore the left half of the graph, then it is a one-to-one function, which we didn't talk about yet. We do that a lot in calculus. So if something isn't a one-to-one function, like over the whole domain, then we'll make one up. We'll say, oh, well, that's okay. We're only going to look at this area anyways. So from x greater than or equal to 0, right? Or was it less than? Yeah, it was greater than. Greater than, it is one-to-one. Okay. So now what we're going to do is we're going to replace the function notation with just regular Cartesian notation. And so that's the first step, right? Plug in y. Let me move my calculator out of the way. Plug in y for f of x. Step 2. We're going to switch, bless you, the x and y's. So now this becomes x is equal to y raised to the 2/3.
You solve for x and then you switch them.
This is what we're doing. So now for step 3, I want to make this look like y equals something. So watch this. Are you guys ready? Put on your thinking caps.
Thinking cap.
If I raise this to the 3/2 and I do the same on the other side, what is 2/3 times 3/2?
1.
Y to the 1. And then this is x to the 3/2. So this is, and then we just got to replace it with our function notation. So here we would solve y equals some stuff, and then 4 we would replace y with the inverse function notation. Okay, so the inverse is equal to x raised to the 3/2. Now the question, you guys, I'm sure that you guys could probably figure that out, but the verify is the tough part, right? So now the verify is, here's how you verify. If I take f of f inverse of x, it will always equal x. So if I plug one into the other, if I make a composite function and I plug one into the other, it will always equal x. How often will it equal x? Always.
Oh. So is this problem really just verifying that it's equal to f?
No, it's both. So you can't verify it unless you know what the inverse is, right? So you have to, it doesn't say you have to find the inverse, But you have to find the inverse to verify the inverse, right?
Yeah.
Okay. So if I say f of f inverse, well, first let's start off with what f of x is. So f of x, remember, was x raised to the 2/3. But now if I say f of f inverse, I'm really saying f of f inverse of x raised to the 2/3. But what was f inverse? F inverse was actually the stuff right here. X raised to the 3/2. So then this becomes x raised to the 3/2 raised to the 2/3, which is x. So f of f inverse is equal to x. So yeah, it's true. It's verified. Boom. Well, bam with the bacon sizzle. Do you guys got that? Get it good.
Wait, no, I don't get it.
You don't get it? We'll just have to do some more.
What did the juniors say? Today, Mr. Adams said